The answer for PODIUM is what we call CUBS, the Contextual Unified Building System, an open data schema that creates a golden thread of data from design through to delivery. And this is not a closed proprietary file type. It's a multi-dimensional, domain-specific object model that captures these critical relationships and dependencies across architecture, structure, and MEPF disciplines. And CUBS is also capable of connecting design logic to financial and supply chain and product data, all in that single unified data model. In PODIUM, buildings are visualized as 3D models, but behind the scenes, they live in CUBS, represented as a graph where every element, its attributes, its relationships, are all connected and all consumable. And now let's look at what we can do when we've captured all of this information within a platform. This new data model can be made practical and is already in use. Design agents automate, generate, and configure designs which incorporate real manufacturing defined data. Every building starts grounded in reality, and within minutes, automation can take you from an LOD 100 conceptual model, conceptual massing, to an LOD 200 schematic design with an engineered structural solution using finite element analysis, and then export schedules of materials which are linked to catalog of real suppliers defined by manufactured components. Imagine this. You are going from the basics of concept to schematic design, but with buildable DFMA components, and you can do it all in minutes and all automated without BIM modelers. That's the magic. So this is where the technology behind all of this and thinking fundamentally diverges from computational design in a traditional sense. Most computational design tools, like Grasshopper and Dynamo, use centralized orchestration. Great for geometry, but the coordinator, that centralized coordinator, becomes a bottleneck as complexity grows. What we built at PODIUM is an engine that uses distributed event-driven choreography. Independent configurators respond to events and messages, running parallel and coordinating organically without the need for a central controller. And this shift from orchestration to choreography enables scalability, flexibility, and cross-domain integration. Multidisciplinary coordination happens concurrently. It happens automated, and every time coordination happens, the model enriches as more information is generated. Product catalogs, costs, lead times, manufacturing, all of this becomes primary data instead of being geometry first. The result is a fully coordinated, buildable, and costed solution in weeks rather than minutes. And for each part of the building we want to configure, we have an execution context, which allows us to understand the flow of decisions and actions taken by design agents throughout the design automation. So with this view, what you're seeing is a very granular look at how specific behavior taken by a design agent and what is the consequence. How do we actually turn those decisions, that decision-making engine, into a buildable design? And we can take conceptual mass and in moments have schematic design using an engineered solution. Not a guess, not a probability, but doing the real work that a structural engineer would have done. We want to reduce, if we want to reduce rework, the answer isn't really in a process that results in a better and faster drawing. It's in embedding engineering intelligence into the design process itself. And so by embedding real engineering logic, material properties, supplier products within this framework of architectural design intent, design agents configure both structural and MEP systems automatically, sizing plant rooms, allocating risers, routing services dynamically, checking against architectural layouts and structural zones, all in real time. And this result is a coordinated engineering solution that integrates architecture, structure, and MEPF. It's buildable, it's costed, it's manufacturable, and it's delivered in the time that it used to take to produce a schematic drawing itself. So this isn't just a vision of the future. It's real working software, which is already being used by property developers and design teams today. And by moving beyond that fallacy that Revit documentation equals BIM, and instead of codifying instead we're trying to codify the how of construction and design. We can turn BIM into a true asset for engineered, buildable solutions that really deliver certainty, economies of scale, and reduced rework. And many of you might think AI and automation will try and replace architects and engineers, but they're not. The goal is to encode the best practices into tools that scale, to act as a co-pilot, freeing you to focus on higher value work.